Okay, so our problem today is calculating the probability that a candy contains erythrocene. And my name is Adia Chaturvedi.
Okay. 1, 2, 3.
Hi, wow, it was so good. Can I have one?
I'm sorry, I'm actually doing a study. So these candies are all from different candy stores, and some of them have this food coloring in them called erythrocene.
Oh, really?
And I'm trying to find out what the probability of getting a piece with erythrocene is.
Oh, I see. Oh, wow, so interesting. Good luck.
Thank you. Okay. 1.
Okay, so our problem is that Ronnie organizes a study that looks at different candy stores and sees what their candy is composed of. So in this study, our conditions are that 30% of the candy is from Sweet Confections, 20% of the candy is from Stella's Chocolates, the remaining candy is from the local Wollaston's. So 30% of this candy from Sweet Confections contains erythrocene food coloring, 20% of the candy from Stella's Chocolates contains erythrocene food coloring, and 75% of the candy from Wollaston's contains erythrocene food coloring. This is our problem key. So SW represents Sweet Confections, ST represents Stella's Chocolates, WO represents Wollaston's, and FC represents food coloring. So our first question is, what is the probability that the candy is from Sweet Confections and contains food coloring? So in order to solve this, we calculate the probability that the candy is from Sweet Confections and multiply it with the probability of food coloring given Sweet Confections. So we have these in the conditions of the problem. So it's 0.30 times 0.30. And then our answer is 0.09.
This is Ha, and I will help you solve the next question. What is the probability that any of the candy contains food coloring? To calculate this, we will need to find each of the probability that each store and food coloring contain is. So for the first one, we will have the probability of Sweet Confection times the probability of coloring given the Sweet Confection. And then do the same thing with Stella and Wollaston candies. And then we plug in the values, which is 0.3 times 0.3 plus 0.2 times 0.2 and plus 0.5 times 0.75 given in the problem, which gives us 0.505. The next question is, what is the probability of grabbing a candy that contains erythrocene and it being from Wollaston? To calculate this, we will need to find the probability of candies from Wollaston and the probability that candy is food coloring given that it's from Wollaston. We will have 0.5 for the probability of candies from Wollaston and 0.75 for the other, which give us 0.375.
So for the last question, I'm Hazelyn and I'll be presenting the last question. And for the last question, what we're looking at is, given that a candy contains erythrocene food coloring, what is the probability that it is from the local Wollaston's? And to solve this question, we can use Bayes' theorem and then plug in the values of what we do now. So using Bayes' theorem, we would do the probability that the candy is from Wollaston's times the probability that the candy is food colored given that it is from Wollaston's, and all of that divided by the probability that the candy is food colored. And the first two variables we actually are given in the problem statement, so we can just plug those in. And for the probability that the candy is it has food coloring, we solve that in part 2 of the problem. So we have that value as well. So then we just plug the values in and we simplify the equation. And once we have simplified the equation, we can round it. So we rounded it to 0.743. So in conclusion, these same concepts that we just talked about here can be applied to lots of different probability problems. And understanding probability is important because you want to build a solid understanding of different problems in the field of computer science.